So before submitting, we have discussed about static routing, right? So just tell me a few points about static routing. What do you have learned?
Yeah, static routes are configured, maintained, and updated by administrator manually.
Right, very good, Teja. So static routing are configuration. Point number one, static routes configuration. Maintain, updated. Routing table updated by network administrator manually. Okay. Next. So to configure static routing, network administrator should know destination networks, right?
Yes.
So today also let me continue the same static routing. So you please try to understand here. In this topology, let's consider first link bandwidth is 10 Mbps. Second link bandwidth is a 80 Mbps and it's a 70 Mbps. The scenario is a to H scenario. Like A is one LAN and H is another LAN. A LAN is 10.0.0.0/8 network and H is 192.168.1.0/24 network. So how to move the traffic from one network to another network? We need to configure IP routing. It can be static or dynamic or default. To configure static routing, the first point is, out of three paths, which path is the best path?
ABH.
ABH, A to B,
ABH
A
or
to D, and A to
ACH or
H.
ADFH. So path selection. So which one is a secure path? Which one is a shortest path? Which one is a fastest path? Which is a reliable path? So that path selection can done based upon the network administrator. Network admin has to decide which one is the best path. So if you decide ABH is the best path, then configuration is IP route destination network ID 192.168.1.0, subnet mask 255.255.255.255.0, and which is the best exit point. That's something we have to decide. So if you think 0/0 is the best path, then you can configure 0/0. Or if you decide 0/1 is the best path, you can configure 0/1. So maybe if you're thinking 0/2, this is the best route, you can configure 0/2. So something we have to configure manually in static routing. So point number one. Okay, so have configured 0/0 is the best route. Have decided 0/0 is the best route. How I have decided is secondary point. Like based upon number of routers or faster or speed, whatever, we'll do later about it. So I have decided 0/0 is the best route and I have configured like this. Then your routing table has been updated with destination is 192.168.1.0/24 network is statically updated. Traffic should go via S0/0. The traffic is going via S0/0 and reply will come back in the same path. Now what if 0/0 is down? If link is down, and do you have a communication from A LAN to H LAN users?
No.
No communication because of you have configured 0/0 is exit point. That exit point is down. Your best path is down. Now again we have to reconfigure second best route manually. 0/1 I have configured. Then traffic will go via 0/1 until unless no communication. So something again you have to do manually. So again your previous link 0/0 has been activated. Then again you have to reconfigure 0/0. So that is what static routing maintenance. Like we need to maintain. We don't have any automatically link, right? If link is down, again configure second link. If again first link is up, again configure first link. The destination information we should know. Router H LAN is what? Router B LAN is what? Router E LAN is what? So if you have 100 routers, networks information we should know, right? The routing tables we need to update manually. So we don't have any automatic updates in static routing. So these are the points about static routing. Now let me continue with today. Let's start with dynamic routing protocol. Okay. So
Balu, one question here.
yeah, please.
Balu, in static routing now, every routing table has to be updated in all the routers.
Of course, yes. Every routing table information has to be manually updated in all routers.
Okay, it means that now if I choose a path of A, B, H, then same thing I have to do in B router also.
Yes. So in B
Okay.
router, we need to be update A router, C router, D router, E, like all routers. See, directly connected networks minus total networks. I mean, total networks minus directly connected networks. You need to configure static routing. Means all indirectly connected networks information have to be configured manually in B router. Similarly, in C also, in C have a 4 directly connected networks, except for remaining all networks to be configured manually in C and E and D and every router with respect to each router. Okay. So administrative work is more in static routing because of we should know destinations and when to configure routing table updates manually. If best path is down, second find again reconfigure second best path. No automatic updates. So administrative work is what more in static routing. Now what if I configure dynamic routing in this topology? So I decided to configure what? Dynamic routing. Point number one, in dynamic routing, if we configure dynamic routing table, dynamic routing, the first thing is a router B networks information will automatically come into your routing table. Router Z information will come into routing table automatically. Router E, router H, D, F, G. Like all destination information will come to add in your routing table automatically. Same like for B also. In B routing table, rest of remaining all routers network information will come into routing table automatically. So here router B information is being come into automatically updated. After some time if router B is failed, then automatically within a seconds router B information has been removed. Again router B is activated. Again router B will come automatically in the routing table. If a new router is added in your network, so new router network ID is 900. So 900 information will come into update automatically in all routers. So dynamic routing protocol, automatic updates we have. Automatic updates. Next point is path selection. Like from A to H scenario, like how to reach A to H can go via S0/0 also, S0/1 also, S0/2 also, right? So out of 3 paths, your protocol will decide which is the best path automatically. We don't need to be decide 0/0 is the best or 1 is the best or 2 is the best. Your protocol will decide which is a best path automatically. And your routing table is updated with that information, which is a best route. Like to reach a 1.0 network, your traffic should go via S00 or S01 or S02. Something can decided by protocol. See, protocol decided S0/0 is the best path. Now traffic is going via S0/0 and reply will come back in the same path. Now what if S0/0 is down? In static routing, if best path is down, so manually we need to reconfigure second best route. Then only traffic is being forwarded. In dynamic routing protocol, If best path is down, within a second, your protocol will choose second best route automatically. If 0/0 is down, then the network table in routing table, the same to reach the same destination, 0/1 will come in the picture in your routing table, and traffic will go via second route within a seconds. If best route is down, okay, now traffic can go via 0/1 automatically. If best path is been activated again back, again your routing table will update it with 0/0 information. So point number 1 is automatic updates. Point number 2 is finding best path. Point number 3 is finding second best path if best path is down. And most important point is, next point is, in dynamic routing protocol, to configure dynamic routing protocol, a destination is not required. Destination is no need of destination networks. So you are in router A, B networks information you don't need. Like C networks information you don't want. Like H information is don't want. Why? This all the information is coming to your routing table automatically. Then why we need to know? So destination network is not required. So destination is no need. Finding best path automatically. Finding second best path automatically. If best path is down. And all the network information automatically come in updating your routing table. If any changes, if any new router is added, or if any down, all routers updated automatically. Then admin work is less or more?
Less. So
Admin
Balu,
work is less.
so
So
once
now
the link,
finally, compared to static routing and dynamic routing, which is the best? Static or dynamic?
dynamic.
Dynamic.
Yeah,
Dynamic routing.
okay.
So here also we need to
What do you say,
reconfigure.
Anand? Anand? Madhu?
Yeah, for the static routing, the information will travel speed, I guess, and for dynamic it will be slow.
Why? How? How can you say?
Because each table should be updated. It's updated automatically to find out the best path. Maybe it will take time, is what I guess. It's my guess.
Okay, very good, very good. Good point. Yeah, Madhu.
But what my doubt is, if A to B, what I am understanding, if A
Yeah,
to
yeah.
B, A to B going traffic, once it's down, we have to start with B, or again it's start with A.
Yeah, only.
A only?
Yes.
Okay.
See, whatever the traffic is going to be,
Mm.
the traffic will be reached to H. If link is down, then further traffic will be stopped in A only. So the traffic have to redirect in another way.
Okay.
Yeah.
Oh, yeah. Okay, got it.
But compared to static and dynamic, which one is the best path? I mean, which is the best one?
Dynamic.
Of course, like, say, people is thinking about because of static dynamic routing advantages we have more, like automatic updates, finding best path, finding second best path, destination is not required.
Yeah,
So
wherever
admin work is
advantages
less.
is there, disadvantages also there, right?
But compared to, if you compare static and dynamic, always static is the best.
Oh, how?
How? That's a good point. So why static is the best means, yeah, Anand, like exactly, you're right. Because of, say, in dynamic routing protocol, what is advantage we have? Automatic updates, right?
Yeah.
What do you mean by automatic
But
updates?
static static
Yeah,
routing, we
let me
have to
explain.
manually enter, right?
Yes, yes, yes. Let me explain. What do you mean by automatic updates?
It will take all routings, this
Means
one
if
B
any
and C.
changes,
Yeah.
if any changes in the network
It will
topology,
take all. Yeah.
automatic updates, right? Okay, let's say
Yeah.
how exactly dynamic routing protocols works. All of you listen carefully. all type of dynamic routing protocol works based upon the neighbor. So what is neighbor in here? In network, neighbor means directly connected device is neighbor. Directly connected route is what? Neighbor. So for A, B is directly connected, C is directly connected, and D is directly connected. So for A, which route is the neighbor routers?
B, C, D.
B is the neighbor, C is the neighbor, and D is the neighbor, right? So for C, which is the neighbor? A
E.
is the neighbor and E is the neighbor, right? Exactly.
Yeah.
Now, what the protocols will do means, what the router means do means, any changes in topology, any link is down or any router is added, any changes will update to the neighbors. What that other neighbor will do? Will update other neighbors. So how automatic update happen means neighbor to neighbor, like all neighbors will update. Example, B serial 0/ is down. Serial 0 is down. Link is down. Now what A will do? So A got the information. Actually B is the neighbor. So if link is down means now A will update. Immediately A will update to neighbors. So for A, C is the neighbor now and D is the neighbor now, right? So what A is doing is immediately whenever B S0 is down, A will update to C. Hello C, one of my neighbor link is down. Same time for D also. So now C got it and D got it. Now what C will do? Oh, I have to update my neighbor. Is updating to the E neighbor. So D update to F. F update to G. G update to H. And E update to H. What is the information? So router H received the same information from the two neighbors. Like enter the topology, enter the domain, neighbor to neighbor, all neighbors has been updated. Because of everyone has to know about what happened in my topology. It's good, okay. But now, what again if your serial 0 is up? Now again will A will update to A will update to C, D, F, like all routers will update. Again if link is down, update to all neighbors. Again link is up. So now you think about it, if have a hundreds of router, thousands of routers, if any change in the topology, now thousands of routers will start exchanging updates. So to send these updates, your routers, I mean your dynamic protocols will utilize your network bandwidth. We pay for bandwidth in the real time. You're purchasing, right? You're paying for the bandwidth. So that bandwidth has been consumed by dynamic protocol to send automatic updates. So point number one. So second point is now to reach a H, like Anand said, like to reach a H, which one is the best path? To find out, dynamic protocols will run some algorithm. Will run what? Some algorithm, right? So to run algorithm and finding the best path, it's taking some time actually. Time like it's some conversation has been happening actually. But in static routing, no automatic updates. No automatic update means no wastes of bandwidth. Complete bandwidth. So whatever the bandwidth you have purchased, so that bandwidth we can efficiently use for what? Data transmission. So complete bandwidth if you use the data transmission, so your data transmission is very faster. And there is no algorithms in static routing. So manually we have defined how to traffic has to be in flow. Then traffic come to routing table and forward it. Faster communication. Reliable. In static routing, who will find the best path? Admin will find the best path. In dynamic routing, protocol will find the best path. So in static routing, if admin is doing the finding the best path means admin will find the secured path. So administrator will choose what? Secured path. So static routes are secured. So static routes are faster. So static routes are no wishes of bandwidth. It's reliable. So these all are advantages of static routing. The drawbacks in static routing is admin work is more. We should know destination network IDs, no automatic updates. So that is why. So static routes are best for what? Small networks. If network size is small, then static is the best. Once if network is become the medium and large networks, of course static routes are best. But if networks are medium and large, even have some drawbacks in the dynamic also because of bandwidth is consuming, like time conversation. Also, still we have to use what? Dynamic routing protocols. So which is the best? Static or dynamic means it depends upon the network size. If network is small networks, then static is a good. Medium and large networks, dynamic protocol. Okay. Second rate is advantages and disadvantages of static routing. Advantages: static routes are secured, reliable, faster, no wastes of bandwidth because of no automatic updates. So static routes are faster communication you can get, secured, reliable, no dropping. The packets are not dropping. Reliable traffic, no waste of bandwidth. But drawbacks, disadvantage what? No automatic updates, need of destination network ID. That's why admin work is more and used for small networks. Now you tell me dynamic routing protocol advantages. Advantage of dynamic routing, please.
Switching the fastest routes automatically.
Finding best path automatically. Okay.
Second best part and automatic updates.
Second, finding second best path if best path is down automatically. Okay. Any changes in topology, all routers will update automatically. Right? Yes. Automatic updates. Changes in topology are updated dynamically. Destination is not required. Means only directly connect network information is required for configuration, means no need of destination network ID. Less admin work. Selecting best path to destination. Finding second best path if best path is no longer available. Right? So we can use for small, medium, large, very large is the most scalable dynamic routing protocols. So generally we use for what? Medium and large networks. Clear? Is it clear for everyone what is the major differences between static routing and dynamic routing? Still any confusions? Yes, please. It's clear for everyone? Static and dynamic routing differences?
Yes, sir.
Very good. Okay. Now we'll see about dynamic routing types. So dynamic routing protocols are majorly two categories. One is interior gateway protocol and exterior gateway protocol. Interior gateway protocol, IGP, and exterior gateway protocol, EGP. So IGP, again, we have three types of protocols in IGP. Distance vector protocol, link state protocol, and advanced distance vector protocol. EGP is only one protocol, which is called the path vector protocol. In distance vector protocols are RIP, IGRP. Link state protocol, OSPF. Advanced distance vector protocol is EIGRP. In OSP of linked state protocol, you have one more protocol is ISIS. And path vector protocol, one and only protocol is BGP, border gateway protocol. So there are dynamic routing advantages and different types of dynamic protocols. So IGRP has been outdated. We are not using IGRP. It has been modified into, it's enhanced. IGRP is enhanced into EIGRP, enhanced interior gateway protocol. So no IGRP because of have some drawbacks is there. I'll tell you what is the drawbacks. In RIP again you have two versions in RIP. One is RIP version 2 and version 1. Right? Yeah. See, here I have one small question. 10.1.1.1/8. This IP address belongs to which class? Which class IP address it is 10.1.1.1/8?
Class A.
Class A. Okay, good. 10.1.2.1/16. Which class IP address? Is it class A or class B?
Class B.
B.
Yeah,
10.1.3.1/24.
yeah.
Which class IP address?
Yeah.
Okay.
Second one is also A, no?
10.1.4.1/29.
Yeah.
Okay. So what is the differences between the first one and remaining all IP addresses?
They are subnetted.
Subnetted.
Exactly. So first one is it's not subnetted, it's not customized. It is not subnetted, right? So remaining are subnetted. So once IP address is subnetted, the range can be class A range or class B range or class C range. It can be any IP address is subnetted. Once it is subnetted, irrespective of the class, if it is subnetted, then no classes. No more classes actually. So these all IP addresses are classless IP address. Classless. We cannot say is a class A or B or C. So just one IP address and subnetted. That's it. Classless. If it is not subnetted, then we can call it as a, we have respect to classes there. We call it as a class full. Means class A or B or C. You can say is a class full. So 2 points here, class full and classless. So class full means the network is not subnetted. Classless is what? It's subnetted. Once IP address is subnetted, classless. Okay.
Sir, /16 means 16 is a subnet, na?
Yeah, subnet mask.
Okay.
So 192.168.1.1/24 is class full or classless?
Classless.
Class full.
Class full.
Yes.
192.168.2.1/29. It's class full or classless?
Classless.
Classless.
Classless. So what are the default subnet mask you're using? /8, /16, /24 for class A networks, for class B networks, for class C networks, they're classful networks. So for class A /8, if you use classful, /9 classless, other than /8, if you use any subnet mask, is a classless. Okay. So classful means it does not subnetted. Classless is subnetted.
How this identify? How to identify this class 8 and class 24, 29 slash?
Classful.
No, normally.
Yeah.
No, class 16 means which subnet it will come. How need to identify?
Yes, we have discussed slash notation, right? So slash 8 means 8 is the number of network bits. Means 1, 2, 3, 4, 5, 6, 7, 8. Means 255.0.0. A subnet mask. Slash 16 means 16 network bits. Means 8 plus 8. 255.255.0.0. Slash 24. 24 network bits. 255, 255, 255.0. So apart
According to
from these
you, you
subnet
told
masks,
class 16 is classful. How it will be classless? That is slash 16.
yeah, that is what. See, class B networks, if you use slash 16, means 128 to 191 IP addresses. These networks, if you slash 16, is a classful.
Yeah, my doubt is here you told 10.1.2.1 slash 16 is you said classless. Here
Yes,
you are
10
saying
is
slash 8
range.
slash 16 slash 24 is classful. How it possible?
10.121 is a range of which one? Like 1 to 126 network.
6. Yeah,
So 1 to 126 networks, if you slash 8,
classful.
is a classful.
Mm.
But 10, 1 to 1, I have used slash 16. Subnetted. So here also 192.223 for these networks. If you slash 24, then classful.
Okay, got it. You were talking about class A, class B.
192.168
Yeah.
1.1 slash 26.
That is classless.
Classless. So actually 1 to 126 network have to use slash 8, right? For classful. But I'm using 1.1.1 slash 16 or slash 24. So 1 dot
Yeah,
IP address I'm using slash 24. Is it classful or classless?
classless.
Classless.
Got it.
Yeah.
Balu, can you please explain again classful and classless?
Yeah. Classful means a network is not subnetted. See, whatever we have classes, it's a class A, it's a class B, it's a class C, right? So class A range, class B range, class C range. So for class A, subnet mask, default subnet mask is 255.0.0.0. Between the range of 1 to 126 networks, if you use slash 8 IP address, slash 8 subnet mask is a classful. For 1 to 126 networks, other than slash 8, if you use any subnet mask is a classless. Means subnetted. Single point, guys. Classful means it is not subnetted, it is not customized. What are the network portion you have? And subnet network host portion, if you use that same, classful. If it is subnetted, irrespective of the class, if it is subnetted, then we call classless. Okay.
Sir, how to find out it is subnetted or not?
Slash notation.
Okay.
Based upon the slash notation, you can find out. Right, here we have some protocols like RIP version 1, version 2, IGRP, OSPF, EAGRP, and BGP. In these protocols, some protocols are classful routing protocols and classless routing protocols. So what is classful routing protocols? A protocol which does not support for subnetting. Protocols which are not supporting for subnetting, that protocols we call what? Classful routing protocols. Protocol which is supporting for subnetting, that protocols are classless routing protocols. So IGRP and RIP version 1 are classful routing protocol does not support for subnetting. That is why IGRP, RIP version 1 are outdated. We are not making use of it. The remaining all are classless, like RIP version 2, OSPF, EAGRP, like all protocols are what? Classful routing protocols that protocol supports for subnetting. You can read this point. Classful routing protocol does not support subnetting, which is RIPv1 and IGRP. Classless routing protocol supports subnetting, RIP version 2, EAGRP, OSPF. Now, one more major difference is classful routing protocol, when it is sending a update to the neighbor, do not send subnet mask in that update. Classless carries the subnet mask in the update. Whenever router A is sending update to B, if he's sending update to B, in that update, they have a 10.0.0.0. It can be /8 or it can be /16 or it can be /29, whatever. That mask is being carried in classless. If it's a classful, no mask, only 10.0.0 network information is being updated. It's clear?
Bharat, keep this slide for a second.
Yeah, sure. So in classful, do not send update, do not send subnet mask in that update. Classless carries a subnet mask in that update. Okay. So now, in CCNA exam, in CCNA certification exam, which is 200-301, you'll get questions from only OSPF protocol. You'll get only OSPF actually. Like RIP, no. EAGRP, no. BGP, no. So for CCNA certification, you'll have a more questions from OSPF protocol only. But for the real time, we use OSPF, EAGRP also, both protocols. I'll tell you for knowledge purpose, in the real time purpose, I'll tell you the RIP, OSPF, and EAGRP protocol also. We'll compare the three protocols. So I'm going to the main deep discussions in RIP and OSPF. OSPF is some advanced we'll discuss actually. Two sessions, 2-3 days we'll discuss about OSPF, and finally just introduction of EAGRP protocol. We'll mainly focus on OSPF, okay? So today we'll try to discuss about RIP and OSPF protocol. Routing information protocol, RIP. Routing information protocol, RIP. It's a distance vector protocol. It's open standard. Open standard means what? We can configure RIP in Cisco router. We can configure RIP in D-Link router. We can configure in HP router. It can be support for multiple vendors. It's an open standard. It's not only in one Cisco. It's an open standard protocol. An RIP algorithm is Bell-Manford algorithm, the scientist name, who developer name. It's classless routing protocol. In RIP, I have two versions. Version 1 is outdated, no more of version 1. So forget about version 1. So version 2. Version 2 is what? Classless, support for subnetting, and it carries a subnet mask in update, right? Yeah. So dynamic routing protocol, best path will find automatically or manually. How to find the best path?
Automatically.
Automatically. So how RIP protocol find the best path? Based upon what? How RIP protocol will find the best path? Based upon what parameters will find the best path? So I'm asking about what is the metric of RIP protocol? Metric means what? Metric is finding the best path.
Method.
Yeah, method. So here, A to H scenario, traffic can go via S0/0, traffic can go via S0/1 or S0/2. There are three paths. If traffic is going by S0/0, let's consider traffic is going by S0/0. From S00, what S00 will do? What is the traffic is coming from the LAN to fast Ethernet switch to serial 00. So what S00 will do means S0/0 hand over the traffic to B. Hand over what? IP traffic to B. Now what B will do? B will hand out to H. Now H hand out to LAN. LAN is your destination, right? So here my question is, from S0/0 to reach a LAN, your destination, how many handover packets has been happened? 00 handout to B, B handout to H, and H handout to LAN. Means how many routers handover packet here? 2. 00 to B, B to H. So that handover packet count, we call it is a hop count. So via S0/0, hop count is 2. Now what if traffic is going by S0/1? If traffic is going by S0/1, handout to C, C handout to E, E handout to H. What is the hop count? Hop count is 3. Via S0/2, hop count is what? Hop count is 4.
4.
Yes. So
A
to
to
reach
B.
a destination H, we have a 3 routes. Out of 3, these are the hop count. Now RIP protocol will find the best path based upon the best hop count. It means the least hop count. So as per RIP protocol, 0/0 is a best path. So traffic is going via 0/0. If what if 0/0 is down? If best path is down, then
It will take 0/1.
automatically traffic within a second, automatically traffic is going via 0/1.
1.
Second best route, second best hop actually. Again, your best path is activated. Now your traffic is redirected to the same, your best route. Second one. Second hop. Okay. 2 hops count. So that is metric of RIP protocol is hop count. So how RIP will find the best path means based upon hop count, or you can say hop count only. You can write it. Only hop count. Is advantage or disadvantage? What do you say?
Route wise it is advantage, but bandwidth wise it is disadvantage.
It is a limited this one. It is a disadvantage.
Why?
Because it is not looking at the bandwidth. It is not looking at anything else. Only just the hop count.
Exactly. That the point is what? Hop count only. It is not looking at the bandwidth. See, in my links here, first link speed is at 10 Mbps and the next link is 80 Mbps, 70 Mbps. So actually to reach a hash, I have a very good links is there, right? Like 80 Mbps bandwidth links and 70 Mbps. I'm paying here. I'm using a very high speed links here, 70, 80 Mbps. Anyhow, RIP it's not utilizing it. So RIP protocol is looking now only the hop count. So here bandwidth is 10 Mbps. Even if it's a 1 Mbps also, RIP will consider this is my best path. So this is a major drawback of RIP protocol is it does not consider bandwidth in metric calculation. In best path selection, it does not consider the bandwidth. It uses only the hop count. Okay, is the major drawback actually. So one more drawback is, say R1, R2, R3, R4, R15, R16. The source is R1, Exit point is S0. From R1 to R16, source to destination, how many passes there now? I'm not asking about how many hops. I'm asking about how many routes, how many passes there from R1 to R16.
Only one path.
Only one path. So traffic has to go by S0 only. Okay, traffic is going by S0. So S0 hand over to 2, 2 hand over to R3, R3 hand over to R4, R5, R6, R7, R8, like R15. Now what R15 has to do? Hand over to R16, right? But R15 is going to drop the traffic actually. You know why? Because maximum hop count. So RIP protocol maximum can hand over in a 15 hops only. If your destination 16th hop is unreachable. The destination is unreachable. So if you want to use RIP protocol, you have to make sure that your destination router is within a 15 hops only. If more than that, it is not reachable actually. Second drawback. It's a limit is there. Some limit is there to maximum hop count limit is there. It is what? 15 is the limit. So RIP will find the best path based upon hop count only, and moreover, maximum hop count is 15 only. So major two drawbacks. It does not consider bandwidth in metric calculation, and maximum hop count is 15. And we have still some advantage also. You know what is advantage is? Let's say router 1, router 2 are connected, router 3, router 4, R5. This is my topology. R1, R2, R5. Now consider links are S0, S1, and S2. Now scenario is a R1 is my source, R5 is the destination. How many passes there from R1 to R5? Traffic can go by S0, S1, and S2. So what is the hop count of S0?
2.
Why S1?
3.
Why 3? Why S1?
2.
2. Why S2?
2.
So why S1, S1, S0, S2, like all are hop count is 2, then which is the best path? In this
Now
scenario,
it will see bandwidth speed. Right?
that is why I clearly said RIP will find the best path based upon hop count. Only hop count, and moreover, we clearly discussed the drawback of RIP protocol. It does not consider, it is not looking at the bandwidth.
Yeah.
Yeah.
Bandwidth.
Then how can something here bandwidth? It's just we
Actually,
look into based upon hop count. Then hop count is same. S0 is 2, S1 is 2, S2 is 2. Then which is the best path?
R1, R3, R5.
I mean, traffic will go via which route? Via R2 or via R3 or via R4?
R3.
R3. Why? The middle in straight line. Huh?
Yeah.
But in
If
R2 is
you,
up and down. So diagram is up and down there actually, no?
It will take the
okay.
first port maybe S0.
Why? So first line, first link, first priority is like that?
Maybe it is by default it will take the first port.
No, actually, see, if it is taking only one link, means complete traffic is going via one link. So then more burden on one link. Why we cannot use the 3 links here? Because of first link when hop count is 2, second link is 2, third link is 2. So all links are hop count is same. So 3 are best routes. So out of 3 are the equal means, then why I need to use only one? So what RIP is doing is when there is a equal hop count to reach a destination, the traffic is going by S0 also, S1 also, S2 also, load balancing. So RIP supports load balancing. So traffic is going by 3 links now. So this mechanism we call load balancing. So RIP supports load balancing when it supports load balancing. To reach destination have a equal hop count. Hop count is equal, then load balancing.
Sir,
If it is
it
equal,
means we
yeah.
are connecting one link, 16 hop counting in one link, 16 hop counting in second and third also.
Say 16 is maximum hop count,
Yeah,
but here
means
number of links here.
Yeah, R1 to R15 is connected in S0, R1 to R15 is connected to S1, R1 to R15 is connected to S2.
Okay.
So that all links are same, it means they are balanced, na?
Yes, exactly. Load balancing will be do.
Yeah, it means we are using that links here.
Yes. Say to reach a destination hop count is equal, then load balancing.
Okay.
Yeah. It's clear about RIP load balancing? Advantage or disadvantage? What do you say?
Advantage.
Advantage. It's doing the load balancing. Is not using only one link. If it's only one link, then more burden on, more traffic on one link. So it's sharing the traffic to all the links. Then faster communication. No burden on only one link. So the advantage of RIP protocol is load balancing. Okay. Let's just look this topology. Directly connect networks I'm keeping here. Allow directly connect networks. The links are upstate. Okay. Right. Now how branch 1 and branch 2 can communicate? branch 1, branch 2, traffic has to go via head office, right? So this is hub and spoke topology. Branch 1 connect to head office, branch 2 is connected to head office. So head office hub now. Branch 1 is spoke and branch 2 is spokes. Now no backup, no redundancy. So I'm making the one redundancy, backup link from branch 1 to branch 2. Okay, let me make a backup link from branch office 1 to branch office 2. Let's say the 0/1 serial 0/1 link here, 0/0 is connected. IP conditions, point to point should be in the same network. So 172.18.0.1, 172.18.0.2. Routing table update. 172.18.0.0 is directly connected to which interface? S0/1. In branch 2, 172.18.0.0 is directly connected to S0/0. So each router, 3 directly networks is there, 3 interfaces. Clear? Now I want to implement RIP protocol to enable communication between these all the branches. So if I enable RIP here, if we configure RIP in branch 1, have configured RIP, which RIP is the best? RIP v1 or version 1 or version 2? Version 1 is outdated, is a class full. So version 2, classless. So I enable RIP version 2 in branch 1 router. Now branch office 1, traffic is being generated. It has to be send update, right? So to send update, RIP uses one to send update. It uses one IP address, which is 224.0.0.9. 224.0.0.9 is a which class IP address? Is it class A or B or C or D? Which class IP address? 224.0.0.9 is which class IP address?
C.
Class C or A or B or D? Which one?
Class C.
224.0.0.9 is a class D, right? Up to 223 is a class C. 224 is class D. So class D IPs are reserved for what purpose? Multicast, right?
Multicast.
So RIP version 2 is started multicast messages to the neighbors. For branch 1, which route is the neighbor routers? Neighbor means what? Directly connected. So head office directly connected to branch 1. And even branch 2 is also directly connected to branch 1. So what your router 1, I mean branch 1 is doing is sending multicast message to the neighbors. Head office 1 neighbor, branch office 2 neighbor. Now head office is received this multicast message. What is a multicast? What is unicast? What is broadcast? So unicast means sending IP traffic from one network to another network. It's a unicast, right? Broadcast means what? Sending IP traffic from one to all devices in the LAN, one to all. Multicast means one to a group. So it started one to group, like means it's a multicast message. Head office received the packet and open it. Head office will open that. Are you coming from where? I'm coming from so and so. Okay, who is the destination? I'm from 224.0.0.9. So we have configured RIP version 2 in branch 1 only. So means head office is not a part of branch 1. So branch 2 is not a part of branch 1. So these two routers is not a group of that, right? Because of we didn't configure RIP in head office and branch 2. So head office will drop the traffic and branch 2 also will drop the traffic. That now if you configured our same protocol in head office also. In head office route also I configured RIP version 2. Now branch 1 head office belongs to same group because of they're running same protocol. So now communication and automatic updates and path selection, now everything will be automatically happen between branch 1 and head office. But now branch 2 also want to add, then configure here also RIP version 2. Now if we configure RIP version 2 here, then all 3 routers belongs to same group. So 1 to a group means from branch 1 to group of routers, same group routers, means same protocol routers actually. So now head office router by seeing the multicast IP address, yes, you are my group because of I also configured version 2. Multicast message matching here actually 224.0.0.9. So 224.0.0.9 is reserved for RIP version 2, is fixed for RIP version 2. Okay. Now, so whenever you have configured RIP in 3 routers, now 3 routers will start exchange updates automatically. Now what router 1 will do? Okay, both are my same group routers. You take my update. So branch 1 is sending routing table information, RIP, routing information protocol. So routing table is sending to neighbor head office. The same information is sending to neighbor branch 2. Now head office is adding here. What the network is updated? 172.16.0.0 is already available in my network. So second network is no need. 192.168.1.0, 18.0 is updating here. 192.168.1.0 and 172.18.0.0. So these two networks is manually we need to update or automatically updated? Automatically updated by which protocol? RIP. Then a code will be shown as RIP. Okay. The same information update to branch 2. Now branch 2 is updating. Right, 172.18 is available, so this network is no need. The remaining network is adding here. 192.168.1.0 and 172.16.0.0 with RIP protocol. Branch 1 is okay. Now head office. So head office is going to update to neighbor R1 and neighbor R2. First neighbor R1, update to neighbor R1. 10.0.0.0 is updated. 172.17.0.0 is updated with R. Now branch office 2 is updating with 192.168.2.0 with R. So here also 10.0.0 is already there. 2.0. Here 10.0. Like this, all 3 routers will exchange routing information automatically and routing tables are updated. Then communication is enabled. Clear? Any networks is missing in the table, any routing table, please check it and tell me. Everything is updated, right? Yes. So everything is updated now, but still, what routers will do here in RIP is, so in R1 routing table, everything is okay. All networks is available. In head office, now all networks are available. Branch 2 also. But still, For every 30 seconds, 3 routers will exchange updates. Every 30 seconds in the network, what R1 will do? Take the same information, Same again and again, the same information exchanging. So these type of updates we call periodical updates. So RIP send periodically some time interval with 30 seconds automatically. It's periodical updates. Advantage or disadvantage?
Disadvantage.
Why?
Because the traffic is, the net bandwidth is continuously being consumed, though there is no change in the network topology or any change in the
Exactly,
any
perfect. Very good point. So RIP protocol utilizes the more bandwidth. So it utilizes the more bandwidth by sending a periodical update. Why the same information again and again you have to send for every 30 seconds? Even the information is also complete routing table is sending to the neighbor. In your routing table, have it 6 networks or 60 networks or 160 networks. So complete routing table, it has to be sent to the neighbor for every 30 seconds. So you practically understand it, then RAP protocol is going to utilize how much bandwidth in the real time. So when update is required? When we need update?
Only when a change is there in the network.
If any changes, if any link is down, you send me the update. Or any new router is added, you send me the update. So if any changes, then update, right? That's good. But what RIP is doing is, if no change happens also, is periodically from some time interval 30 seconds, is sending the update and update the same information. So please try to understand the drawbacks of RIP protocol. So if you understand the drawback of RIP protocol, the next protocol advantage you can clearly understand it. Because of next is OSPF. So we use OSPF in the real time. Okay. So there are a lot of drawbacks in RIP protocol. It does not consider in the bandwidth in metric calculation, and the hop count is limited, right? And moreover, it's sending the periodical updates for every 30 seconds. It lies the more bandwidth. Let me write the few points about RIP protocol. So what type of updates in RIP and what is an update? What type of updates in RIP protocol? I mean, when RIP will do update?
Periodically every 30 seconds.
So RIP, what type of update means what? Periodic updates for every 30 seconds. Okay. Then what is there in update?
Complete routing table.
Yeah.
Entire ARP table.
Routing table.
Complete routing table. A routing table can be 100 networks or 200 networks or 300 networks. It has to be sent.
This routing table is stored in the ARP only, right? ARP table is also routing, or it is different?
No, it is a different. ARP is different, routing is different.
Okay.
ARP will contain what, which network and which MAC address is, like so-and-so computer IP address, that MAC address information.
Okay.
Routing table routes, how to reach this network. The route is defining here. Best routes information will be there in routing table. So complete routing table will be stored, will send as update for every 30 seconds. One more point is, let's say this is my routing table. So how many networks is there in routing table now? One, two, three, four, five, 6 networks is there, right? Yeah, let's consider a few more networks is in routing table. 6, 7, 8, 9, 10, like we have 100 networks is there in my routing table. Total 100 networks. Now what RIP will do? It has to be sent periodically for 30 seconds. What? Complete routing table means complete 100 network had to be sent update to the neighbor, right? But again, one more drawback is each update packet contains maximum 25 networks. One update maximum can have what? 25 networks only. But in my routing table, how many networks is there? 100 networks, right? Then what RIP will do? So it's going to do divide the packets. First 25 networks will send as a first update packet. Now wait for 30 seconds. The next 25 networks will send as a second update packet. So next 35 networks will send in third update. Last 25 networks will be sent as a in fourth update. So your 100 networks is divided into 4 update packets. Because of each update maximum can have 25 networks only, but in my routing table 100 networks is there. So each update again 30 seconds will take time, 30 seconds delay. So so-and-so user, so-and-so R5 user is waiting for 98th network. So when router 5 will get 98th network? So router 5 will get in the first update? No. Second update packet? No. Third update packet? In fourth update packet, they have a network of 98 network. So RIP protocol conversation is very slow conversation. If any link is down, it will send, it can come to know after 30 seconds only now. Right? So conversation is what? Very slow conversation. It is not much intelligence protocol. You know why? Because example here, every 30 seconds is sending update, right? What if head office router is down? I mean, if neighbor is down. So neighbor is down. Still you want to send a update packet to head office router? Actually, no need because of your neighbor is down, right? But what RIP is doing is even the neighbor is down, also it still keep on sending update. Complete routing for every 30 seconds. Up to 180 seconds will be sent. Even the neighbor is down also. So up to 180 seconds is not receiving, it is not getting the reply. It is not receiving the update. Then your R1 can come to know, okay, it has been 180 seconds. So generally we'll get every 30 seconds reply, but it has been 180. Maybe it is not there. It is down. Okay, after 180 seconds, R1 knows about R2 is down. But still then why we need to maintain the R2 information in the routing table? No need to maintain. Its whole information. up to 240 seconds, like up to 240 seconds, if there is no reply, then standard information has been flushed. Flushed after 240 seconds. So it's RIP timers. Update for every 30 seconds. Invalid means neighbor is invalid. 180 second. A neighbor information is flush after 240 seconds. These all are RIP timers. So conversation, protocol conversation is very slow. So these are the drawbacks of disadvantages of RIP protocol. It does not consider bandwidth in metric calculation. Maximum hop count is 15 only. Utilize the more bandwidth by sending periodically complete routing table as update. And each update contains maximum is 25 networks. So you have 100 networks divided into 4 updates. This means conversation. Protocol conversation is very slow conversation. The timers are also 30, 180, 240 seconds. Okay. So this is how RIP protocol works, and I'll continue with RIP configuration. How to configure RIP. In router configuration mode, router RIP. Then we'll get into router mode. In router mode, we have to enable version space 2. If you don't define this command, then version 1 will be affected. So you should configure version 2 command. Then after, you can advertise your networks. Network space, network ID. Means directly connect network IDs. That's it, exit. Verification. Show IP route or show IP route or IP. To check RIP timers, show IP protocol, to check RIP updates, debug IP RIP. Then you can monitor RIP packets is pending a periodical updates or not. Verification commands. Yeah, let me configure RIP. Yes, please. In R1, show IP route. We have 3 directly connected networks. So to configure all dynamic routing protocols, only directly connect network information is enough. No need of destination networks. Destination is not required. Only directly connect networks. Config mode, router RIP, version 2, network 172.16.0.0, network 172.18.0.0, network 192.168.1.0. That's it. So this is R1 RIP version 2 is enabled. Now what router 1 will do? So router 1 will start sending periodical updates to the neighbor with the multicast 224.0.0.9. Let me monitor that. How can check that RIP packets? I mean RIP updates. To check RIP updates, debug IP RIP. So debug IP RIP. So RIP protocol debugging is on. Now let's wait for 30 seconds and we can see the update in the screen. So we have configured RIP version 1 or version 2? We configure version 2, right? So version 2 is a class full route. Class full or classless? Classless. So classless carries a subnet mask in update. 172.18/16/24. It is carrying the subnet mask, right? So this is update. RIP is sending version 2 update via 224.0.0.9 multicast. So one update. In the next 30 seconds, one more update. So like this, what RIP will do for every 30 seconds is keep on sending update and update to the neighbors. Okay, with the second update. So point is here, it's sending version 2. It's a sending. So it's only sending. Why it is not receiving? Why it is not receiving?
For R2 didn't apply.
Exactly. Like in R2, we didn't configure, right? So we have to configure in R2 also. So let me configure in R2 and R3.
Oh no, router 1 takes 180 seconds to check their one server is down or
No, let's keep on sending it. Router RIP version 2, network 10.0.0, network 172.16.0.0, 172.17.0.0. Yeah. Have seen this. Received version 2. Received after receiving again. It's building update entries. Let's build update entries and routing table is this one. So it's a sending and it's a receiving also now. And to reach zone network, one hop, there is one hop actually. So to reach zone network, there is metric is 2. Metric means what? Hops in RIP. Okay. So let me configure in R3 also. See R1 version 2, R2 version 2, R3 if you configure version 1, no communication. So 3 routers should be same version. Version 2, 172.17.0.0, 18.0.0, 192.168.2.0. Understand? The 3 routers we have configured RIP protocol. Now they are exchanging routing tables and exchanging for every 30 seconds also. We'll see the routing table information. And to stop monitoring on the screen, you can use space all command. If you check show IP route, is the routing table. So here R. So what is the parameters we need to be understand here in routing table entry, which is very important. So here, the first one is protocol code. So which protocol is static or directly connected or OSP or RIP protocol code. Next is network with mask. Subnet mask, network with mask. Network mask. Okay. Protocol code. Next. Administrative distance. Metric. Next hop IP address. The last parameter is exit interface. So these parameters we need to be understand for every routing protocol, guys. Point number 1, code. Point number 2, 3, 4, 5, 6, 7 points need to be focused on routing table. R indicates RIP.
What is
So
AD?
on net administrative distance.
Admins.
120?
Yes. Static routing AD value is what? 1.
Okay.
RIP is 120. OSPP is 110. Like EHRP is 90. So what
Who will
is this values and who will calculate and how it can come? I'll tell you later. It's just you remember these values for protocols. We'll have a small scenario about these things. We'll discuss about it later. You just remind these values and for RIP protocol, OSPF and EHR. Okay. Let's say some ranking. Rank 120 for RIP, rank 110, rank 90, rank is 1. First rank for static actually. Yes. So sounds on network and mask. Administrative distance of RIP is 120 and how to reach standard network. In this scenario, from R1, how can reach to R2, which is standard network? So traffic can go via S0/0 also, S0/1 also, right? If traffic is going via S0/0, what is the hop count? Hop count is 1. If traffic is going S0/1, S0/1 to R2, R3, R3 to R2, means what is the hop count 2? So which is the best hop?
S0
1.
slash 0.
S0/0. The same point here. Metric is 1, means hop count is 1. And via next hop is what? 172.16.0.2 means S0/0 hand over to 172.16.2 and exit point is S00. So next hop IP is available and exit point is available. S0/0. Like this.
Between timing is there, what is that?
RIP timers. 30 seconds timer, right? 21, 25, again comes 0, When it becomes to 30, again it can become 0. Again start from 3, 4, 5 seconds. So when it's come to 30, again refresh 0 like this. If neighbor is down, it go for up to 180 timers like that actually. Okay. Now what if S0/0 is down? Serial 0/0 so down. Then what is the entry in routing table? What entry will get? Same network. Metric is now what? Metric is 2 hops. Because of S0/0 is down, right? Yeah, via 172, you can see 18, 172, 18.0.2, and 0/1 entry can get actually. Let me check that. Show IP route. So how to reach standard network RIP 120/2 means metric is hop count is 2 via 18.2. Exit point is 0/1. So automatically second best path is being came into routing table. They're communicating. If routing table entry is there means it's communicating is there. Again your best route is being activated, no shutdown. Then 0/0 will come back in your routing table. Have you seen this? 10 dot network 122.1.16 S00. So which protocol, I mean which version is enabled? Show IP protocol you can use. Sending updates every 30 seconds. Next due in 26 seconds. Invalid is 180, I mean for whole is 180, flush after 240. Sending version 2, receiving version 2. Right? Like this we can understand about RIP protocol. And administrator distance is 120 default. So this is how RIP works. It's clear? Any doubts? Yes, please. Any doubts? All right. You just try to practice an RIP protocol and you try to make some list about RIP advantages and disadvantages. The next session tomorrow will continue with the link state routing protocol, which is OSPF protocol. So to understand OSPF, you try to please prepare and make a list of RIP advantages and disadvantages. Based upon that, we'll discuss about RIP protocol. Okay. Thank you.
Yeah, thank you, Bob.